Okay, so the purpose of this video is to look at some common squaring and square rooting mistakes that Algebra 1 students make. So in order to introduce the first common mistake, what I'm going to do is start with a right triangle. And let's call one leg A and one leg B and one leg C. So all of our Algebra 1 students know that a great way to relate these three sides is with Pythagorean theorem. We've got a right triangle here. So let's just write out the Pythagorean theorem. A squared plus b squared equals c squared. That's the relationship of the sides in a right triangle. Great. So the error comes up when we want to try and solve for c. So how are we going to solve for c? Well, we have c squared. In order to undo something squared, we need to square root it. So let's square root both sides. Right there, boom. So we get the square root of a squared plus b squared equals square root of c squared. And what a lot of us want to do is this. We just want to say, okay, that square root is going to undo all the squareds, so we get a plus b equals c. That looks really nice, and I wish that was the world we lived in, but I think unfortunately this step is going to end up causing some trouble. So let's do this. Let's put in numbers for a and b. So let's let a be 3 and b be 4. So following the same logic above, what's going to happen is we're going to square root there, we're going to get rid of the squares, so we get 3 plus 4, right? So that's going to give us 7. Okay, so that follows the logic above. Let's try a different way. Instead of getting rid of the squares there, let's simplify inside the radical first. So 3 squared is 9 and 4 squared is 16. Now let's combine those underneath. We get a root 25, which becomes 5. So we started with the same thing but got two different answers. So we need to determine which method is correct, right? We want to make sure we're doing things right. So let's draw the triangle that we just made up there. Remember, I let A be 3 and B be 4. This should look familiar. This is a special right triangle, right? This is a 3, 4, 5. It's a Pythagorean triplet. So, which is the right method? I think the bottom one is going to work for us, right? That first method gave us an incorrect answer. We know that if we have a right triangle with one leg 3 and one leg 4, the other one has to be 5. It's not going to be 7. So this works, this doesn't, okay? So we are never ever going to do this. It turns out, if we look down here, when you take that square root, the right side will work nicely because it's multiplication, right? C squared, if you take the square root of that, you just get C. It's the addition that gives us the problem here. So we can't simplify under the radical the way that you'd like to when there's an addition or subtraction. Okay, let's move on to a common squaring error. So let's look at this problem. Now, if we have a plus b quantity squared, here's what we all want to do. We want to distribute this squared inside, so we get a squared plus b squared. All right, so let's look at that for a second. It looks nice. It looks like we're just distributing the squared and we get a squared plus b squared. It looks pretty. It looks easy. It looks great. Well, let's take a step back and think about what squaring means. So let's just take a squared. A squared is the same as saying a times a, right? Okay, so let's take a plus b and square it, and let's expand it a little. Let's write it out a little bit. So aren't we going to get this? A plus b quantity times quantity a plus b. So what happens here? Well, we can think of this a plus b as one term, this blue circle here. And if we had one term times something in parentheses there, wouldn't we want to use the distributive property? I think we would. So we can think of this as distributing that a plus b across that other a plus b inside the parentheses. So what that's going to look like is we're going to multiply the a plus b times a and then times b. All right, this is a little different than what we did up above, but let's just keep following this. So that's going to give us this. So we're going to have a plus b, that blue circle, times the first term, plus a plus b, that blue circle, times the second term. Now let's distribute again, right? We need to distribute that a across these parentheses. Okay, here we go. Now we're going to have this mess, but it's not so bad. If we simplify it, we get down to here, a squared plus ab plus b squared, and one more step gives us a squared plus 2ab plus b squared. This looks similar to what we did up above, but we have that middle term, that 2ab. So the a plus b quantity squared, we can't just distribute that squared, and it comes back to that addition sign. That addition sign just causes trouble with our exponents. So instead of doing this long method where you kind of doing distributive property twice, someone came up with the FOIL method. FOIL. So what this stands for is first, outside, inside, and last. And what it is a way for us to remember and make sure we don't forget anything while we're foiling here, while we're doing these binomial times a binomial, because we don't want to forget any terms. So if we look at this again, basically what we want to do is let's take the first two terms, a times a squared, boom. Outside, the outside terms are a times b, boom. Inside terms, b times a. Rearranged, we get another a times b, right? Multiplication's commutative, so we can switch those. Last, b times b, b squared. So if you notice, each term in that first binomial is multiplied by both terms in the second binomial. So we're just making sure that we multiply every term by every other term. That's really what we want to do here. And when we simplify, we get the same thing, a squared plus 2ab plus b squared. So let's make sure we never do this. We cannot distribute a squared exponent across a binomial.